Hi everyone, and welcome to this three-part series on the chemical nomenclature taught in Chem 3A. In this video, I'll be going over the rules and steps required to name alkanes and cycloalkanes. As a general overview of this video's contents, I'll first introduce you to IUPAC and the purpose of chemical nomenclature. This will be followed by a quick review of the structure of an organic molecule and then a procedural review of how to name alkanes and cycloalkanes according to their respective IUPAC guidelines. Finally, we'll do two worked examples, one where we name a structure and another where we generate a structure based on its name. Part 2 of this video series will cover stereochemistry and naming alcohols, while Part 3 will go over naming alkenes and alkynes. Alright, so getting into it, IUPAC stands for the International Union of Pure and Applied Chemistry. It is essentially a federation that sets the standards by which compounds are named, which is also known as chemical nomenclature. In this video, I'll be teaching based on the 2019 IUPAC standards. Now, one important thing to note is that many molecules can have a common name in addition to their IUPAC name. For example, this molecule is known as trichloromethane by IUPAC, but it is also commonly known as chloroform. Now, just to review, a typical organic molecule, that is one that does not contain any inorganic atoms such as metals, will typically comprise of a carbon chain known as a stem, along with its various substituents, which branch off of the stem. This terminology will allow us to better understand how to name organic molecules. So with that being said, let's learn how to name alkanes. There are four main steps you want to follow. First, we want to locate the stem, which is the longest chain of carbons of the molecule. In the case that there are two carbon chains of equal length, the chain with more substituents is the stem. Secondly, we should determine and name the substituents. For now, these will either be an alkyl or halo group, and you can see the next slide for details. Third, to index the locations of each of the substituents, we'll need to number the carbons, beginning from the end that will allow the first substituent to have the lowest number. If there is more than one possible numbering scheme, use the one that puts a lower number on the second substituent, or until there is a point of difference. Lastly, all that's left to do is assemble the name by ordering the substituents along with their numerical locations alphabetically, with the name of the stem at the end. Ignore the prefix of straight-chained and halo substituents, but consider that of branched alkyl substituents when ordering alphabetically. This last part will be explained in more depth in a future slide. So for now, we're just going to practice with two very general substituents, either halo groups or alkyl groups, the latter of which will often be seen as a straight chain or a branched chain. The halo groups are named very simply. Depending on whether the X is a bromine, fluorine, chlorine, or iodine, your substituent will be named with a bromo, fluoro, chloro, or iodo prefix, respectively. For a straight chain alkyl group, the prefix will be determined by the number of carbons in the substituent. A 1-carbon substituent is called methyl, 2-carbon is ethyl, 3-carbon is propyl, and so on. Branched chain alkyl groups, on the other hand, have two different ways they can be named. If it takes the form of one of these structures, they can simply be referred to by their common names, which are listed here. However, if the substituent does not resemble these specific alkyl groups, you can simply name it as if it were a separate molecule. You would find the stem, which in this case would be referred to as an alkyl, and name the substituents. Carbon 1 must be the point of attachment of the substituent to the stem. Overall, the name of the substituent will go in the full molecule name in parentheses. The last thing we need to account for is how to denote the number of each substituent present. The way this is done is through numeral prefixes. The presence of multiple halo and straight chain alkyl groups is denoted through prefixes such as those found in this table. Branched chain alkyl groups that are named with common names also follow this convention. Branched chain alkyl groups that do not follow the common name convention use the prefixes bis, tris, tetrakis, etc. that go in front of the parentheses instead. These aren't very common, so I wouldn't worry too much about memorizing these particular prefixes. You'll definitely want to know all that are found in the table below. Once again, don't forget that only the prefixes of branched chain alkyl groups are factored into alphabetizing the substituents. So to put it all together, the full molecule name will take the form of the alphabetized substituents and their numerical locations, followed by the stem name, which will depend on the number of carbons in the longest carbon chain. You should memorize the stem names for chains ranging from 1 to 12 carbons in length, which are listed in this table. If we were to name this molecule on the right, we'd first notice that the longest chain is 8 carbons long, resulting in a stem name of octane. Next, you want to determine the identities of the two substituents. One of them is a simple ethyl group and the other is a tert-butyl group. If you didn't recognize it at first though, don't worry too much, as you can use the other method of naming it instead. In that case, it would be a dimethyl ethyl, and we'll go into more detail of how to do this in our worked examples. In terms of numbering, you would have to label the rightmost carbon as carbon 1, this carbon right here, since it will result in the lowest number for the first substituent, ethyl on carbon 3 in this case. If you had started from the leftmost side, the first substituent would have been located on the first, second, third, fourth carbon, which is just farther than if we had started numbering on the other side. So once this is determined, we can put everything together in the name. Out of our two substituents, dimethyl ethyl will be listed before ethyl because D comes before E in the alphabet. Notice that if we included the di prefix when alphabetizing the two substituents, because that particular substituent was a branched chain alkane. When putting it all together, be sure to include the specific positions of each substituent. For example, 1,1-dimethyl ethyl is located on carbon 5, while the ethyl is located on carbon 3. Thus, the name of this molecule is 5,1,1-dimethyl ethyl 3-ethyl octane. Naming cycloalkanes is a lot like naming alkanes, with only a few tweaks here and there. First of all, when naming a cycloalkane, the stem is always the ring with the most carbons. Even if there's a straight chain alkane with more carbons than the ring always wins. When the ring is the stem, it is called a cycloalkane. Substituents follow the same conventions, with ring substituents called cycloalkyls. The numbering system is more or less the same, except that for monosubstituted cycloalkanes, carbon 1 is automatically the point of attachment of the substituent. For disubstituted cycloalkanes, you want to try to number the rings so that the substituent that will come first in the name will have the lowest numbered location. Finally, assembling the final molecule name works exactly the same way as with naming alkanes. Simply alphabetize the substituents and then place the cycloalkane stem name at the end. Be sure to pay attention to which prefixes you should consider when alphabetizing. Hint, we only want to be paying attention to that of branched alkyl substituents. Okay, so now that we've gone over all the rules of naming alkanes and cycloalkanes, let's try out a few problems on our own. Before we do that, I wanted to acknowledge that all of the worked examples in this video are from Professor Volhart's test bank, and you can look at the source information below for more details on that. In this question, we are presented with a very strange looking molecule with the instructions to name the following molecule according to the IUPAC rules. Luckily, we've just gone over how to do that, so let's just follow the steps outlined a few slides back. Step 1. Locate the stem, which is the longest chain of carbons of the molecule. To do that, we need to count each possible carbon chain. So why don't you take a minute to pause the video and explore all the different ways you can do that. When you're ready, move on to the next slide. Okay, so you don't have to list them all out like I did here, but you should definitely practice visualizing them in your head, especially if you didn't find all 5 possible carbon chains. As we're looking for the longest chain of carbons, we can go ahead and eliminate the carbon chains that are 7 or 9 carbons long. Once that's done though, we have to determine which 11 carbon stem to choose. That's where 1A comes in. Notice that it says, in the case that there are 2 carbon chains of equal length, the chain with more substituents is the stem. We're going to need to count how many substituents each carbon stem has before we make a decision of which one to choose. If we look at the one on the left, it has 1, 2 substituents, while the one on the right has 1, 2, 3 substituents. Thus, the carbon chain on the right will be what we are basing our name off of. Now that we've determined which particular stem we should be focusing on, let's quickly determine what its name should be. Pause the video before we move on to the next slide and reveal what a chain 11 carbons in length translates to in English. Hopefully, you realize that our stem is called an undecane. If not, be sure to review the table on naming saturated hydrocarbons, as it will be crucial to your ability to name alkanes. Next up, we need to determine and name the substituents. Let's first circle these substituents and number their carbons so we can easily determine what kind of alkyl group they are. Once that's done, all that's left to do is actually identify them. I encourage you to pause the video and name each one before moving on. Overall, we should have 2 ethyl groups and 1 butyl group. Again, you should review the prefixes for alkyl groups if this felt uneasy. Moving right along, we should now number. With our carbon chain, there are 2 ways to do this. We can start numbering from the leftmost end or the rightmost end. Starting from the leftmost end, the first substituent will be located on the 5th carbon. Starting from the rightmost end, the first substituent will be located on the 3rd carbon. If we want to start from the end that will grant the first substituent the lowest number, which end should we start with? Pause the video and answer in your head before moving on. If you said the rightmost end, you're absolutely right. This way of numbering the carbon results in the first substituent having the lowest numerical location. Finally, in the last step, we need to assemble all the information we've gathered in naming this molecule. Let's first list all the components of the name we've compiled before putting it all together. Going along the indecane stem, we first encounter an ethyl group at position 3. Next, at position 5, there is a butyl group. Lastly, at position 7 is another ethyl group. With all our substituents listed, we should check to see if there's any way we could combine them. Sure enough, we have 2 ethyl groups, so they can be written together as 3,7-diethyl. Once that's done, all that's left to do is alphabetize our components. But wait! Don't forget that the di prefix should not be considered when alphabetizing because it is not referring to a branched chain alkyl substituent. Therefore, you'll want to put the butyl before the diethyl, not because B comes before the D in diethyl, but because B comes before E in ethyl. Now you can pause the video to piece the name together, and once that's said and done, the final answer is 5-butyl-3,7-diethyl undecane. Now obviously this was a long drawn-out process for the purpose of honing in on the specific thought process you'll want to go through when naming an unknown molecule. With enough practice though, it'll become like second nature. Now to switch things up a bit, we'll try drawing a structure from its name. The name we've been given here is 3,4-dibromyl-butyl cyclohexane, which sounds like a cycloalkane. As a general game plan for solving this problem, we can probably take a similar approach to naming a molecule, which to summarize involves first the stem, then the substituents, followed by numbering and finally assembling the name. We want to start with the stem so we can establish a canvas of sorts on which to add our substituents. The name indicates that the stem is a cyclohexane, so let's draw that in. Remember that the word hexane indicates a carbon chain with 6 carbons, while the cycloprefix tells us that these 6 carbons form a ring. Next, we can analyze the substituent name given, 3,4-dibromobutyl. What we must first notice is that there is only one substituent, so it does not matter where on the ring it's located. This will be a special substituent since it is in parentheses and the butyl tells us that it has a base of 4 carbons. So let's draw that in. Attached to the butyl are 2 bromines, as indicated by the dibromo prefix. Bromines are specifically located is denoted by 3, 4. Let's number our substituents starting from the point of attachment so we can determine where to put the bromine substituents. As always, pause this video and draw out what you think the answer is before resuming the video. The final answer is this structure right here. And with that, I want to thank you for watching the entirety of this long video. I sincerely hope it clarified confusion you may have faced and that you can use what you learned in your courses. Feel free to check out the PEACE website at peace.berkeley.edu if you're interested in obtaining resources or advice for your classes and your overall Cal experience. If you're interested in signing up for our one-on-one tutoring advising services, fill out the form at the link below. And if you can, like this video and subscribe to our YouTube channel for more educational videos.